Thanks so much for having me. Thanks, Martha. Thanks for introducing me into. As he said, creativity is very important. I'm sure we all want to be more creative. Is there anybody who doesn't want to be creative? You can raise your hand, or not. So I'll talk about this project that we started in the Center for Interdisciplinary Brain Sciences and Research about 2.5 years ago, where it was a very ambitious project. We wanted to see, can we enhance creativity in adults? And if we can, I mean, that has been done before, but if we can do that in adults, what changes in your brain? Not just that what part of the brain is engaged in when you are doing something creative, but more importantly, if we enhance creativity, and it's a big if, then what changes do we see that happens in the brain structure, in the brain functioning, in the brain connectivity? That's one of the studies I'll talk about, and also give you some brief insights about our new studies, as he mentioned about collective creativity, as well as a study we are doing with kids, and we're trying to see how the creative brain develops. So to begin with, we have to define creativity. And that's my favorite cartoon of all times. So I'll give you a second to read it. Okay, awesome. So when I hear the laugh, that's my cue, move on. Often described as development of not just original ideas. The idea has to be useful in some way. It has to be appropriate. If it's just novel, that's not enough. That's how people have tried to define creativity since, I think, 70 years ago. They are trying to find new definitions, but this is a definition that just sticks with everybody. It makes sense to them. You can go in deep and create some psychological definitions, but I mean, this is very simple and easy to understand. And it doesn't just is useful in problem solving, it's also useful in problem finding, and more often avoiding the problem to even occur. And the third thing that we believe creativity has, the main component of creativity is, to us, is inspiration as well as perspiration. So and then that flows with the appropriateness and usefulness as well. Now, briefly, the importance of creativity. It's not just the big C, we call it big C creativity, which means something that you develop a new idea, make a light bulb, and it changes the life of everybody forever. That's the big C creativity, changing the whole domain. But there's also something called little c creativity that you do every day. You find a new way to go home, which has less traffic. That's some sort of creativity. It's useful. It's a novel idea. Similarly, the sushi guy, he found an awesome way to sell sushi. That's very creative to me. And creativity is not just linked with, as I said, problem solving. People have shown in several studies, creativity is highly associated with psychological well-being, with resilience, how you bounce back when you fail, with longevity, with avoiding stress. And you may have heard of this term called flow. That has been shown to reduce a lot of stress, perceived stress especially. In addition, in business world, in industry, and I just looked at this, somebody did a little bit of data mining on LinkedIn blog. They found that employers, the first keyword, like the top keyword they want to use is creative, and all the employees, or people who want a job, that's the first, like the most used word is the creativity. So apparently everybody wants to be creative, everybody wants to hire creative people. So it's important, so let's study it. Now, how do you study creativity? Now, since I think the first lecture on creativity and we should study came in 1957 by J.P. Guilford. And since then, people have studied creativity in different ways. Some people focus on the person, and they say that's the most important thing. You have to focus on personality. You have to focus on the motivation, why people do what they do. Some people focus on the process. They say, no, we're going to focus on the creative process itself. So you may have heard of these words very commonly: divergent thinking, convergent thinking. It's kind of the idea that if I give you a cue, can you come up with a number of ideas? That's divergent thinking. And given the number of ideas, can you come to a common solution? That's convergent thinking. And then there's a new process that we will start beginning to study called insight or aha moment that usually happens in the shower or the bathtub, as you can see there. And then the third thing people study is press or pressure, the environment. There was a very interesting study done on siblings where they found that if you are the second child in the family, and if you have an elder brother, chances are you're going to be more creative. I don't know how many of you are in that scenario. I'm not, so I'm not creative. But that's one thing that kids, the environment, the family dynamics also plays a great role in enhancing or in giving you this ability to be creative. And the last thing people study is product. They want to study Nobel laureates or creative writers who have won several awards. And then they want to study how, more biographically, how their creative process works, what makes them more creative than other people who do not get awards, for example. In our study, we focused on person, process, and to some degree on the product as well. We couldn't do all of them, but we tried to do some parts of it. Now, creative capacity enhancement is also not new. If you saw the Stanford report that was published, I think last week, there was a paper which showed that if you walk every morning, you tend to be more creative. So simple walking can do it. As you can see, I'm walking while talking. Hopefully, I'll be creative by the end of the talk. And then there was another paper which showed that if you meditate, that also enhances creativity. This is from Mike Posner's, who's a very famous psychologist, his lab. Several people have worked in domain-specific training that enhances creativity, and this is usually linked to the industry, where you get training in one particular aspect of the industry domain that you're working on. There have been several papers on that. The third one is very interesting. I don't know if you know about this. There's something called fourth grade slump in creativity. Apparently, across cultures, we have seen that kids, when they move from third to fourth grade, their creativity slump. And nobody knows why that happens. You can blame education. But we don't really know whether it's brain development, it's really education, is it societal norms, is it that we make them sit in a classroom like this, as opposed to, up till third grade, they can sit wherever they want. Whatever they do is cute, but the moment they enter fourth grade, right answer, wrong answer. So it could be something like that. So that's another thing we are studying. And then the last thing is team brainstorming. That has been studied a lot as well, where people say that when you're doing brainstorming session, they promote the idea that you should submit ideas anonymously beforehand, before even the meeting starts. That has shown to bring up new creative ideas. So all this has been done. What has not been done is, again, I said in the beginning of the talk, is what changes in the brain when we enhance creativity, and that is what we wanted to see. We wanted to see whether if we do domain general, not specific, general training in adults from a variety of backgrounds, then can we enhance creativity? And if we can, what happens to the brain? And so I'll talk about 3 studies. The first one I'll talk in detail because we have cool results. The second 2 I'll give you very brief insights on because I don't even have enough time to talk about the other 2 studies. So this study, Creative Training Program, was funded by Larry, if he's here, and D School and Hasso-Plattner Institute. Here again, we had very simple 3 goals. Can we enhance creativity in adults? If we can, what changes in the brain? And the third one is very interesting. If you enhance creativity, and in the previous studies, most of the creative enhancement was short term. Like they did not measure, they did not assess 1-year follow-up, 2-year follow-up to see whether the creativity you enhanced is still there or is it lost. We believe it's more like a muscle that you have to work on every morning. If you don't work on it, it gets loose and it's not useful. So these 3 questions we tried to answer using this first project. How do you enhance creativity? We went to D School. There's a beautiful course called Creative Gym. You haven't checked it out, you should check it out. Grace Hathorn, she's a faculty in design school, and she teaches this course. And she has a very simple, basic idea. She says that most of us are inherently creative. What is missing is that we do not take action. I'm sure all of you must have, if you haven't started a company yet, most of you have companies, but if you haven't, you're like a postdoc like me. We have amazing ideas, but we never work on anything. We're too scared to act. And her class is all about enhancing bias towards action. You have an idea, start building it up. You can take a duct tape and a scissor and a pen and a pencil and whatever you can find, just create the first prototype. And using these exercises, she has a lot of 1-minute exercises where people have to just do it. And when they do it, initially they fear, like, what am I going to create? Is it going to be useful? Yeah, I don't know. But when they see everybody is creating crap, they feel okay. They don't mind. But that's the first step. And by the end of the class, they realize that, whoa, we can do so much with just this much. Wow, that's amazing. and new insights come. So that's her course. And as it was a study, so we had to have a control training. So nothing against Chinese Mandarin language, but we took it as a control training where the idea was to learn calligraphy so you can imitate as best as you can. So basically we were trying to control for people coming to the classroom, learning this separate training where they would have absolutely everything else but creative thinking process. They would have an instructor who's very enthusiastic, same as in creative gym, but who would teach them, and they would practice 2 hours of calligraphic writing every week. So the design was pretty straightforward. We started with first time point. We had 36 participants, 18 of them pseudo-randomly assigned, so they were matched on age, sex, education. First half got creativity training, the second half got language training, and 2 hours a week for 5 weeks, so 10 hours, just 10 hours of training. Then they were assessed again, and this big tunnel thing I'm showing, it's not the NDE experiment, it's the fMRI, big beast that we have at Stanford that we use to measure very precisely your brain activity, both spatially and roughly good enough in temporal resolution. And then there was a crossover. So people who got creativity training now were enrolled in language training, and the same thing the other way around, and then we assessed them again 5 weeks later. And then we did a follow-up. It's not in the slide, but we did a follow-up training, and then we did something called a booster shot. So we found actually that the creativity did slump, and we wanted to see whether if we give a quick booster shot of 4 hours of training, like a vaccine, can that bring the creativity levels up? So that part I'm not going to talk about today. I'm coming from the psychiatry department, and we love assessments, as you can see. So we did a lot of them, ranging from executive functioning to memory to motivation, behavioral inhibition, approach. We also created a new test for creativity, which I won't talk about today. But I will talk about these two things, which we found very nice results on. First, I don't know how many of you are familiar with this. How do we measure creativity? That was the biggest hurdle. Torrance test of creativity is something that we found has the highest face value. It has been done in more than 250,000 people. So we thought, hey, that we should try this test. And just to give you an idea of what this test is you give participants incomplete figures, like these 3 figures shown here, and you give them 10 minutes. And you tell them, do whatever you want. Try to create a unique story out of your picture. You have 10 minutes, and try to create something as unusual as possible. You don't necessarily say the word creative, not to put any pressure on them. And then we assess these final figures in terms of fluency, flexibility of number of elements, originality, uniqueness, elaboration, how elaborate the designs are, and the last, and the resistance to closure. I'll tell you what I mean by that. It's a very interesting aspect of creativity. And then they also are supposed to give titles in the end, so the abstractness of the title. Now this test is not just testing for divergent thinking, as in like number of, I give you a brick and you come up with 10 different solutions. That is certainly some part of creativity, but they are trying to assess something more deep. And that's why this test has been very famous. Just to give you an example, so somebody was given this incomplete figure, and they came up with that. And at first I'd be like, what is that? What are they trying to do? And this has been rated very high in terms of resistance to closure. Why? And the way they define it is resistance to closure is something is openness of lines indicates that participant is not going to force anything to an obvious solution. So if you were to give this to me, I would make a triangle out of it right away, and probably even fill it up with dark black ink. But this guy is apparently completely opposite. And that if you think about it, it makes sense intuitively that you're not going to go for an obvious, simple solution. He's resisting the closure as much as possible. So that is considered very interesting. And if you have noticed, he turned the page upside down. So that's something called non-conformity. He's not conforming to the rules. So these are the aspects that this test measures. Another example is here. This is literally outside the box. He just didn't want to stay in the box at all. I would probably make a dog head out of it, but he made a hat and a nice guy with a mustache. And then this is my favorite. Given those tiles, he created something. It's a literary reference as well. I don't know if you know about this book, James Joyce and the Confessional. It's such an interesting thing, and he has a beautiful title about it. So These are the kind of tests we use to measure creativity in the lab. And the reason I'm showing these to you is that they are not very simple as you give me a cue and I give you 10 answers, which may or may not be novel. But this is trying to measure something deeper than that. So we did the same test, and I'm going to show the first 2 time points, where we found that, and sorry for this busy slide, but we've basically found that due to the creative gym training as compared to the language training, we found enhanced creativity on resistance to closure as well as elaboration scores, the red arrows. The other were very close to significance, like P was 0.07 or 0.06. So it was perhaps the low power we think is because of the less number of subjects. We only had 15 in each group in the end. Some people dropped out. But if we would have had around 30 or 50 subjects in each group, we would have had good effect size, as they call it. So interestingly, we found people to be more creative. And then we tested also on this executive functioning task. We wanted to see what happens to these executive functioning. And I don't know if you're familiar with this experiment. It's called Stroop task, where we give you these funny-looking things. And in the first condition, you just name the color. Second, you just name the word. Third becomes more interesting, where you name the ink, not the word. And then the fourth is even more interesting. You have to name the ink only when it's in a square or in a rectangle. So this is just to enhance, just to see whether, given these complex rules, how do you handle them? And can you switch? There are different rules for different conditions. Can you switch back and forth quickly? This measures cognitive flexibility. Interestingly, we found that creative training did not enhance number 3 and number 4, but it did enhance number 1 and number 2. That was we really did not expect that. We were expecting the interference trainings to be very high. Now that could be because these guys are from Palo Alto. They're already plateauing on the IQ level, and they're very high, no doubt about it. But we found that this basic color naming and word reading, they were significantly enhanced. And I think this is the reason, this is kind of giving you a clue about the training where the idea was to bias towards action. Just do it, just do it, just do it. I think that's because of that. The basic information processing was enhanced dramatically. This is a very significant result. So when the and I think it could be that in the other conditions where there was higher interference, they would have had even more enhancement, but it could again be a power issue. We did not have enough subjects to get the significance there. Okay, and now talking about the neural aspects, neural correlates of creativity. We assessed neuroimaging using different kinds. We did structural brain imaging, functional brain imaging. If you know about structural, is more about like how the plumbing looks or how the wiring diagram in the brain is. Functional is more how it works, how given a circuit, given a new input, how different areas of the brain activate or deactivate. And then resting state is another kind of new upcoming neuroimaging technique, which I'll talk about as well very briefly, where you want to, when you're not doing anything, you're not engaged in any task, it's very interesting to neuroscientists. They want to see what kind of patterns emerge in your brain and what kind of patterns die out and then emerge again and die out. That gives us a really tremendous knowledge about the brain functioning, the baseline. So we actually found changes in the baseline of brain functioning with creative training as well. And the last one is diffusion tensor imaging. That is trying to find out whether the wiring itself was changed. And you may guess with just 10 hours of training, well, not going to happen. But we actually did find some changes. I won't talk about that today. But apparently, the lesson is our brain is very adaptive. And if you just close your eyes for 5 minutes, and if I do an EEG on you or some other neuroimaging test, I can guarantee it, your visual cortex wiring will change. Just 5 minutes. So our brain is very, very adaptive. You can see it when you go from a very dark room to a very lit room or lit room to a dark room. You can see, oh, you can't see anything. And in 3 minutes, you start seeing stuff. So it's very adaptive. Neurons are very adaptive in making that happen. So the biggest hurdle in this experiment was, how do you measure creativity inside an fMRI scanner when people are lying down and there's a huge banging noise happening? It's very hard. You can probably sleep, but it's very hard to measure creativity. Several previous studies have done this by asking the participant to think about creating something new, or to just press a button, or, as I said, given a response, you give back, oh, I give you a brick, how many uses you can come up with. So very basic things. We wanted to do something different. And we took Pictionary, because I love the game. So we thought, let's try something very different. It's diversion and conversion. You have to come up to a solution. So if you don't know the game of Pictionary, if you don't know, you should meet friends more often. It's the game where you're given a word and you're supposed to draw it, and the other person, the other team, is supposed to guess the word from the drawing itself. And it's a freely expressive. How do you make people draw in the scanner? So we came up with this not very beautiful looking, but very good in terms of working MR-safe drawing tablet, because you cannot take anything magnetic or metallic inside the scanner. So this was made here at Stanford by us, completely plastic, except a tiny chip, in just $80. And we wanted to see how people, when they freely express themselves, what happens in the brain. It was a game environment. That's very important for creative measure. If you tell people to be creative right now, not going to happen. It has to be a game, social game, something like that. And it has a useful outcome. You're not just creating, again, I'm going back to the same example, not just creating something which is abstract. You're creating a picture that somebody has to guess. So it has a useful use, a useful product in the end. Here are just some examples and the task design. And we only give them 30 seconds to draw. Usually I think it's a minute in the game. We give them 30 seconds because we want to squeeze as many trials as possible. And here I'm just showing you some examples for salute, graduate, snore, vote. They're not the best examples, but they give you an idea. And obviously these guys practiced drawing on the tablet beforehand, so they knew how to use it. But they certainly did a much better job than me. And what did we do with this data? We hypothesized that if you subtract, so by the way, there's Pictionary drawing, and then there's a control condition. In fMRI, you just cannot measure something raw. You have to have a reference, because the brain is always active. So you want to subtract the reference from the condition you're interested in, and you want to see what is different in this condition as compared to control. So we had a control condition which was drawing zigzags, so that was controlling for a very basic motor drawing. So they were just drawing zigzags on the screen for 30 seconds. It's not the best control, but we try to just focus on subtracting the motor activity, making the strokes on the tablet, using the tablet. So when you subtract these two, whatever we see in the brain is hopefully only linked with spontaneous improvisation, because that's what they're doing, and perhaps some aspect of creativity. And then these drawings were then blindly rated by people outside the scanner. They rated these for representation, whether they actually represent, can you guess the word out of it, and how creative they are. And we chose similar design as in TTCT, like elaboration, how unique is the drawing, how easy it is to guess, how many elements they have. For example, if somebody's drawing the word salute, and if they just do this is like the most common architecture, then if people also add a flag, or they add an eagle, or they add, I don't know, something else, so these extra elements were also counted towards the creativity of the figure. And we did this longitudinal analysis. We had 2 time points, so we did something called group by time analysis. We wanted to see, compared to creative training compared to language training, and time 1 compared to time 2. It's called group by time interaction. In the contrast of Pictionary minus zigzag, what changes in your brain? And these are the areas that we found to change. So here it's the right hemisphere and left hemisphere, and the red blots are the activation map. And they were mostly located in the prefrontal, on the right-hand side, actually. And when I saw these results, I was like, oh, aha. I had an insight as well, which turned out to be wrong, but I had an insight for a change. And that was, hey, the prefrontal, everybody says right brain is supposed to be creative. And everybody says that prefrontal is very important in terms of creativity. So I was very happy until I plotted the results. And then I found, I don't know if you can see it clearly, but so in almost all of the areas in prefrontal, so the red line is their activity for those 30 seconds before training, and the blue line is after training. So it was completely opposite. It's actually the reduction in the prefrontal was associated with creativity. I don't know if it makes sense to you. It was like, whoa, what's happening? And in the language gym, it was completely opposite. They were using more neural resources, the language people, to do the same task as compared to creative people who were actually now using less neural resources. And why does it make sense? Because we feel that, and this kind of goes back to Grace's class that she teaches, is the less you think, the more you create. And the more you create, the more chances of being creative. And that's what we are finding. The less these prefrontal areas are highly engaged when you're trying to control your attention, when you're trying to select a response, when you're trying to think too hard, basically. And what we find is you let go and you become more creative. So it's a very, very beautiful result, I think. And then interestingly, the more you let go, the lesser the activation, the higher you increase on the TTCT scores. So you become more creative. That's a confirmation. Now, sorry about this, is a very busy slide, but as I told you about the baseline resting state brain, researchers have found that during resting state, it's not just white noise in the brain. It has these different networks that kind of emerge and then go down. So for example, if you put me in the scanner, and more often than not, I'll be thinking about food. So, or planning something, or looking at the scanner's beauty and getting scared. So that will bring about probably the food planning network or planning network, which go up for a while. And as I'm thinking about the food or planning my day, it would die out. Then I'll think about some visual features, and the visual network will light up, and so on and so forth. And what we find, you can measure these networks, and then you can see how the networks connect to each other. This is called between network connectivity. The basic idea is that the network on the left I've shown here is called salience network. It's again attention regulation network. And on the one on the left is called motor network. It just lights up here on the motor cortex. And what we found that in after training, people who were in the creative gym, the attention regulation network has less influence on the motor network. Now, I hope that doesn't mean that they would go in the public and slap somebody because they don't think. No, I think it's more that they're evaluating less and doing more. They have a higher bias towards action. And that was confirmed with the second imaging modality as well. So just to quickly conclude, that we found that people were more creative. We found that they were more focused. And the neural imaging results are telling us that they accentuated more on idea generation than on idea evaluation. So in the next 2 minutes, I'll talk about the next two studies. That'll be hard. So after this study, we wanted to see whether, as I said, in kids, there is a slump in creativity in 4th grade. And this has been known across cultures. It has been shown in Asia, Europe, America as well, that creativity slumps around 4th grade. We don't know why it happens. And in this study, this was funded by Lucille Packard and Stanford Children's Health Fellowship. We're trying to figure out, is it just brain development because of which your creativity slumps? Because I don't know if you know this, but kids around 8 years old don't have really response inhibition. They cannot inhibit their responses. But around that time, 9 or 10, that faculty comes in. So that might help you better understand your kids. They just can't do it. And maybe that is why when they're learning to inhibit responses, that's where their creativity is slumping, because they're inhibiting their ideas now as well. But this is a study, we're doing a longitudinal study across 3rd and 4th grade using near-infrared spectroscopy, because it's very hard for the kids to stay still in the scanner, in the fMRI scanner. And NIRS is a new technology which hits the sweet spot between EEG and fMRI, because it can give you beautiful spatial localization. Like if you have a channel here, you are measuring, you can guarantee it, you're measuring activity right below that. So there is not like EEG, where there's volume conduction, and anywhere you put the electrode, you're getting signal from everywhere else. So we're measuring this longitudinally, and as kids go from 3rd to 4th grade, and the second group as kids go from 4th to 5th grade, to see how creativity and their brain development changes. In the last study, thanks to MediaX and Martha, we are trying to study the neural correlates of collective creativity, so to speak. And the idea here is most of the previous studies have only looked at idea generation aspect, for example, brainstorming. We want to see how do you not just generate ideas, but refine them. Because I think that's where probably the creativity, when you're hit with constraints, when somebody says something, somebody else says something, how do you manage to go through that that space of solution space. So we are doing this with the help of MediaX in Stanford, where we have 5 fMRI scanners. So we can actually look at brain data. This is called hyperscanning, multi-person scanning simultaneously. So while they're engaged in some creative process, we can collect their brain data simultaneously and then see how the brain coherence, so activity between brains, is getting correlated or not correlated. Sorry, I'm out of time. I just want to thank everyone, our funders, our lab, Alan, my boss, and the director of the Sipser Institute, Grace Hawthorne, our faculty, and the rest of the team. And thanks so much for hearing me.
Because not so much time, I would like to take one question or comment.
Oh, you have a question?
Is there? Please.
Did any of your students happen to be dyslexic or ADHD?
No, all these were healthy individuals to begin with, but we are going in and now testing. We plan to do it at the end of the year with mood disorders, especially patients with bipolar disorder. They happen to have enhanced creativity at the onset of the disorder. That is something very interesting to see. No, but not with dyslexic or ADHD, not yet.
Are you planning to do any studies around moods at different times of the day and the kinds of context that we're now actually able to capture with devices and how that might impact creativity sort of through the day?
Yeah, that's a great question. We did have temperament measures in the study, which we didn't find any correlation, but perhaps we need sensors which can collect data throughout the day, and that can help us better, pinpoint what's happening. That's a good point.
Okay, thank you very much.